Welcome back. Today we're revisiting the dashboard that we built last time. I'm adding in some of the checks that should have been there and fixing some of the code. Also adding a couple of new features. One of those features is the ability to set the corner where the dashboard appears, and you can see in the background shot here that the dashboard is moving from corner to corner as the bar changes. In the next video we'll go on and enhance this further and create the dashboard you can see here on screen. It has multiple columns, looks more professional. Although this dashboard is showing the same information in each column, there's no reason why you couldn't be showing different information here. And this is just a nicer looking dashboard for you to use. Then in future videos after that, we'll go on to show how you can run this dashboard separately from the instance of MetaTrader where your EA is running, which could be useful if you're running your EA on a virtual server and you don't necessarily want to log into the server to see this dashboard. You can run the dashboard on your local desktop and monitor the service remotely. And then we'll move on and create an expert advisor that uses all of these components that we've been building over the last few weeks. On screen I just have the original dashboard that we created. I've included a comment block for the version history here to show what we're going to be doing today. Adding error checks for the invalid index numbers, which I mentioned last time we weren't doing. Then the ability to set the corner. So if you remember, this originally only paints in the top right corner. This will let you set one of the four corners, and the horizontal margin was hard-coded last time. And then some additional property settings along with some techniques. And this video will also show some of the things you need to consider when you've already created a class and you want to update that class and it might be in use in places, the sort of things you need to think about to make sure it remains backward compatible. First, let's just take care of the index validation because that's a very simple thing to do. I'm just going to create a single function. So this is just a single function, is the index valid? And it's a simple inline function, just if the index is greater than 0 and less than the size of the row array, then it's a valid index. I'll be using that throughout the code. There's really nothing more to say about it than that. Now if I'm going to be setting the corner and the horizontal distance, I need to make a change here. So I can add in a variable to store the corner number and the X distance. Along with introducing those variables, I'm going to change the constructor because we now need to be able to accept that new constructor with the corner and the horizontal distance. But this is the point where I'm considering I may have code out there that's already using this class, and I have an existing constructor that only takes name and the Y distance. So I don't want to change that and risk breaking existing code. What I'm going to do, and I'll just paste for the constructors, I want to maintain compatibility with the earlier version. So I still have the C dashboard constructor that only takes name and Y distance. But now I'm calling a new init function where I'm also passing in a default corner of 1 and a default X distance of 8. But I've now added a new constructor which takes all four arguments, name, corner, X distance and Y distance. And I'm not calling the init function directly from here. You'll see in the body of the function how I'm using this. The main reason for separating it is that I want to set a default value for corner. You could pass a value of X distance that is positive or negative, and that's fine if you want to set your dashboard off screen with a negative X distance. But corner needs to be in the range of 0 to 3. So I want to perform validation and set a default value of the corner on initialization. It's fine with the earlier constructor because I know that I'm setting the default value to 1 and it can't be anything else. But just to avoid having a corner passed in of -1 or +27 in this constructor, and you'll see in the body how I'm initializing the corner before I use these values. And then something similar here because I now have a revised init function that needs to take arguments. Let me just paste in. But I also want to maintain compatibility. So here's the old init function, which I've maintained. But I'm now calling the new init function directly from that. And here I'm passing in the variables of corner and distance that I already have. That's because they will have been set as part of the constructor, and I'll show that just in a moment, rather than put default values here, because if they've already been set once and you're calling the init function again from outside, note that this is a public function, so you could call this anytime. If you're calling this again from outside and not passing in a corner and a distance, I don't want to change the corner and distance that may have already been set. So this is all about maintaining the compatibility with the previous version. There's no change to the add row or the get functions, but I am making a change to these set row functions because I'm just adding some additional properties that you can set independently. I'm simply adding the ability to set the color, font and size independently. I don't actually need these functions. I'm quite happy to continue to use the set row in most of my code, but this is just an example of how we can do this, and it also allows me to introduce some templating, which I will just move to now. Let me just scroll up. I'm creating the templates as private functions. Just going to place them in here before the constructors. Templates are effectively generic type functions. So by using the template keyword type name T, I'm able to create a function definition here that uses a type name of T, which is determined at runtime based on the type of the variables passed in. So all I'm doing here is creating definitions of two Boolean functions, one to set value and one to set specific row values, and we'll see what they do later in the code when I write the function bodies, but they will be used by each of the new properties that we're creating, each of these set properties, because the code inside each of these would effectively be the same. So by creating the template, I can pass this through then to a generic function. And then the next change or new functions that I'll be adding, because we've added a corner and an x distance, I'll just insert functions here for get the corner, set corner, get x distance and set x distance, and we'll see those later as well. Just paste this in ahead. So this is my version 2 constructor. I'm taking the name, the corner, distance and y distance, x distance and y distance. This is the significant difference, this colon m corner 1. This is how I'm initializing the corner to a default value. I'm not too worried about the x distance. If you want to set a negative x distance and have a negative border on your dashboard, then that's fine. But a corner that is not in the range from 0 to 3 simply will not work. So I'm going to default that to 1. In classes, you cannot simply set a variable. Let me scroll back up here. I could not do as I can in standard code and say int m corner equals 1. That doesn't work in a class. So the way to initialize those variables in a class is to build in colon, variable name, brackets, and default value here. That will set the value of 1 on the m corner variable before any other code is performed that can set that value, and then I'm simply passing to the init function name, corner, x distance and y distance as the same arguments that were passed in here. The reason I'm doing that separately here for the corner in the init function, I will then try to set the corner, but if I've passed an invalid value, it will simply ignore the invalid value, which will leave the default that I've set. Now, along with that, the init function changes from this, taking the extra arguments, corner and x distance, and then as well as set y distance, I'm setting the corner, the x distance, and the y distance. So here in calculate y row y distance, things do change depending on the corner that I'm using, because 2 of the corners are at the top of the screen and 2 are at the bottom of the screen. And I still want my rows to be numbered from the top row to the bottom, but their distance from the edge of the screen will be reversed if they're in the bottom corners. So the first thing I'm going to do is add a simple function here. No, I'm going to add it here. So just to tell me if I'm using a top corner or not, and all that's telling me if corner is 0 or 1, then it's a top corner. Now if I come down to the calculate row y distance function, I'll just replace that. So if this is a top corner, this line is the same as it was before, but this line changes slightly if it's a bottom corner, where I'm setting the y distance as the default if we're on the bottom row, and then I'm counting upwards. So the distance from the bottom is index +1 plus the size of the row below. Now, the ability to set corners affects a lot of functions here. So this set row y distance function also changes. And I'm changing this in two ways. I'm introducing the ability to handle the top or bottom corners, but I'm also taking some of the code that actually sets the y distance and I'm extracting that to a new function. So let me just replace this with the new set row y distance function. So again, is it a top corner? Then as long as the index is, or calculating from the index up to the size of the rows, I'm going to set the y distance for a single row. This is the new function that I'm introducing, because that saves me reproducing the code of this in two different loops here. Now the set single row y distance, I have to create a function for that. I'm just going to begin separating these so it's easier to see the groups of functions. So set single row y distance index, and now down to the body of that function. Now here I'll paste in the new single row y distance function. I'm using my isValidIndex check here, and then the calculate row y distance, the existing function from above, and then I'm simply setting the row value for that index to the y distance. Now let's have a look. This set row value is the templated function, so let's create that so that you can see what that's doing. I'm going to place the template functions. I'm going to write both of them here that I defined, the set row value and the set value function, because they're very similar. So let's begin with the set row value, because this is the one that we were calling. I'm passing in an index, a variable, and I'm passing this by reference using the ampersand, and it's of type T. So this variable could be a string, an integer, a double, anything. And I'm passing a value, and that value needs to be the same type because I'm using the same type name definition here. So these two need to be the same. And it's really just a shorthand inside my code. So here's the piece of code that I'm actually executing. If the variable that I already have, so this is my mrows index something. If that's equal to the value that's being passed in, if it's not equal to the value being passed in, then I want to update my variable with the new value, and that means something's changed on that row. So I'm also going to call the DrawRow function for the index and return true. Although I don't think I use that anywhere here, I'm just returning that to indicate that something has changed, and code can use that later to know if there's a need to take any further action. Otherwise, if nothing's changed, if the variable and the value are the same, then I'm just returning false. The other function that I've written is to set value, and this is used for the parameters of the dashboard itself, not for a single row. And it works in much the same way. I'm passing in a variable by reference and a new value. If those are different, then I'm setting the variable to be the new value, and I'm calling the new drawAll function that I'm creating to redraw the entire dashboard. This is good if I'm changing the corner, for example, because any change to the corner will mean I need to redraw the entire dashboard. And again, I'm just returning true if something's changed and false if nothing has changed. So let's go back to our functions. So back to the set single row y distance function, I'm calling the generic set row value, passing the index. I'm passing mrows index.y distance by reference, and I'm passing the new y distance, which I've just calculated. And this set row value function will take care of assigning Y distance to the M rows index Y distance if needed, and redrawing that row if there's been a change. Now in the SetRowValue function, or rather in the SetValue function, I introduced a DrawAll. So let's go and create that function now. I'll just go here to DrawRow. And I'm adding two new functions. I'm adding DrawAll that will draw the entire dashboard. I still have a DrawRow function, but as we'll see in a moment, I'm changing the DrawRow, and a lot of the code that was actually doing the painting on screen, I'm moving out to the DrawSingleRow function, because this makes it easier for me to draw a single row or to draw a loop, or to run a loop where I'm redrawing multiple rows. So let's go back. And let's begin with the DrawAll function. Just insert that. And this, as you'd expect, is a simple loop through every row. But again, I need to consider whether I'm on a top corner and I'm counting from the top of the screen down, or whether I'm in a bottom corner where I'm counting from the bottom of the screen up. So for each of these situations, I'm either counting from row 0 to the last row, or I'm counting from the last row up to row 0. And using I minus minus if I'm counting up, I plus plus to count down. The set single row Y distance will just calculate that value for me, and then I'll redraw that individual row. The DrawRow function, I mentioned that I was taking all of this code that actually paints on the screen, and I'm removing that to a separate function. So I will completely replace the DrawRow function. Let me just take this out. So the DrawRow function now, test for the valid index, drawing a single row at that index. If it's a top corner, then I'm going to set the Y distance from the row below, so index +1. But if it's a bottom corner, then I want to set the Y distance for the row above. Remember, I'm still numbering the rows from top to bottom, but the border is measured by MetaTrader from the top or bottom of screen. So if I'm in a bottom corner, I need to measure this distance from the bottom. And that was the reason that I've created this separate function for drawing a single row. And let's move on to that now. All right, now moving on. So here I've just inserted the body of the draw single row function, and it has a lot of the code that we had before in the DrawRow. I still have isValidIndex. I'm checking that obviously multiple times if I've called this from another function, but it's best to include this in multiple places. Still setting the text object name, search for the object, setting the object all the same. Here then, setting the size, font, text color. Nothing there changes, but previously you'll remember I had a hard-coded corner, so now I'm using the mCorner variable to set the corner, and then I'm using the xDistance variable to set the xDistance. The Y distance doesn't change. Still calculating the Y size based on the size of the font, and then still causing a rewrite if needed. Now the delete all function, I made a mistake in this last time. It would work, but it was very inefficient. So I'm replacing this with something much simpler. You can see in the new version above, object delete all is still there, so I'm just deleting everything on the screen that might be related to this indicator. But rather than go through delete rows, which caused a lot of overhead that was unnecessary, ultimately all I want to do is delete everything in the M rows array, and I can do that just by resizing it to 0. So this is much cleaner. Now moving on to the property functions, the addRow function doesn't change. We have the same basic attributes of each row. I don't need to check the index because it's not being passed into the addRow function, it's simply going to the last row. The SetRow function does change because I've added in the check for index, but nothing else in that needs to change. SetRowText though, this does change, and I will put the new function above the old so we can see the difference. I've added the check for the valid index, that's just a standard check, but then instead of setting the value and then drawing the row, I'm using the templated SetRowValue function which we discussed earlier. Now I've added a number of other functions that set the color, the font and the size independently. I'm just going to paste those down below now, but they are all the same as the SetRowText function because I am using that templated SetRowValue. So let me just paste those in. So let me go back up here. So that's my setting text. The color, you can see almost identical code. All I've done is replace text color here. Font, all I'm doing is putting the font in here, and the size, I'm just passing the size. You may be wondering why I don't just check the valid index inside the SetRowValue, and that is because, if you note here, I'm already using the index to get the variable that I'm passing into this function. So I really need to check the index number before I go in there. Now for the extra properties that I've added for the overall dashboard, I don't just have a Y distance anymore, and I'm also going to be using the templated function for the Y distance. So let me replace those. Set corner, here I have a special check. If the value is less than 0 or greater than 3, then I won't set that, which means that M corner will remain where it was previously. And remember, back to the initialization, this is why I do that initialization. If you called the constructor with a value of 5, then this function would simply return without setting anything, but at least by setting the default value in the constructor, I've fixed a valid corner number. Then the X distance is simply a set value, and the Y distance is also using the setValue function. And those should be all the changes we need in the class. The delete rows function doesn't change. So let me try compiling this just to make sure that I haven't got any syntax errors in the class. That works. Now I'll create an indicator from the indicator we had previously, just to show how this operates. Now first, I've got the dashboard example from last time, and I've loaded this up simply to demonstrate that my constructor still works and I've maintained compatibility with the earlier version. So I can compile that and it still compiles, so I've got compatibility there. Now I've also created a second example based on the first, so not a lot of changes. I'm including the same file because this is the same dashboard class that I'm including. I'm still creating a variable that is a pointer to the dashboard class. I'm now calling the new constructor. I'm still calling my indicator test, but I'm passing a corner in here. I'm beginning at corner number 0, which is top left. I'm setting the X margin at 8, which is the same default that I had before, and 15 as my default Y margin, just to keep away from the edges. Then I'm using the add row on each of those rows. Same values I was using before. The arrow indicator, whether the trend is up or down, bid, ask, spread, and seconds to next bar. This is just data that we're pasting in there. And you'll remember the add row function didn't change, so I haven't had to make any changes here. Still deleting the dashboard when I finish. Down here I've made a small change. Previously I was moving the dashboard vertically each time the bar changed. I'm still doing that, but now I've also added a change of the corner. So what I'm doing is setting the corner based on wherever the current corner is with the getCorner function. I'm adding 1, and this %4 takes the modulus of 4. So as soon as I get to a value of 4, I'll set it back to 0. So it will rotate through the corners 0, 1, 2, 3, and back to 0 again. That's just to demonstrate the use of the setCorner function. The set Y distance is still there. It will still gradually creep by 5 pixels until it reaches a value greater than 50, and then go back to 15. Down here I'm doing much the same things, but I've included SetRowColor and SetRowText here for the arrows, where previously I was setting all of the values at once. This is just to use the new SetRowColor function. Then down here for bid and ask, I'm still just calling SetRowText. For the spread, same thing, I'm just using SetRowColor to change the color to yellow or green depending on the size of the spread, and I'm using SetRowText separately, and then again SetRowText for seconds to next bar. So this is using the same class that I had previously, but now I'm making use of the new functions. I'll compile that, and now I'll just change over to the chart, and I'll open up two charts, one with example 1 to show that it still works, and one with example 2 to show the difference. So here I have the original version 1 of the indicator using the revised class. Let me, example 1, yes. And on the second tab, I've loaded up the second version of the example, where I'm actually moving the corner from 0, where I started, through 1, 2 in the bottom left, and 3 in the bottom right. I'll just accelerate the video here so you can see it move around. I might also need to make that a 1-minute chart. So we've revised the class here and added some condition checking for the index to make sure that's valid. We're able now to place the indicator in each corner. I did say in the last video that I would tell you why I normally place it in the top right, and I forgot to do that. The main reason for that is if I place it on the left hand side, I can find that I'm running into bars and indicators of price lines on the left hand side. The right hand side I can keep clear by shifting, using this button. I can shift the chart to the left, and I can keep the right hand side of the chart clear. So that's why I typically choose the right hand side, and I choose the top just because it's convenient. But as I mentioned earlier, in the next video we will look at the chart showing in the bottom of the screen with multiple columns, a much more professional look. I hope you found this useful. Please leave a like if you did, and if you'd like to see the next video or any others in this series, remember to subscribe and click the bell icon, and you'll be notified when we release new videos.